just happened there. If that really happened, I would be dead now. But what is a black hole really? Let's check Google. According to Google, black holes are a region of space having a gravitational field so strong that no matter or radiation can escape. How? Basically, black holes are matter that has been squeezed into a tiny, tiny space, just like this. They are infinitely dense matter, and their gravity is so strong that it will suck in anything that comes too close. Nothing can escape a black hole, not even light. Just so you can understand a little better, here's an example. If a star 10 times as massive as our sun were to be turned into a black hole, we would have to squeeze it into a ball with a diameter the size of New York City. If Earth were to turn into a black hole, we would have to squish it into a ball with a diameter of about 1/2 inch. So like a small walnut. That's crazy. So there are many, many different types of black holes, and they all differ in size. Black holes can grow throughout their lives, so they can also change from one type of black hole to another type of black hole. But it takes forever.
One eternity later.
Let's start with the biggest black holes, the supermassive black holes. They were first predicted by Albert Einstein in his general theory of relativity. Their mass can vary from millions of suns to hundreds of billions of suns, so they can be huge. And there's evidence that every galaxy, including the Milky Way, has a supermassive black hole at its center. So our black hole, at the center of the Milky Way, is called Sagittarius A star, and it has a mass of about 4 million suns. So, considering it's a supermassive black hole, it's really rather small, but it's still huge. Let's talk about stellar black holes next. Their mass can be between 5 and 50 times as much as our sun. So they're really hard to detect because scientists have no idea how many there are. There's only an estimate, and the estimate is that there are about 10 million to a billion stellar black holes in the Milky Way. But we only know about 10 of them. Then in between stellar black holes, which are really small, and supermassive black holes, which are huge, we have intermediate black holes. And those have whatever mass between 50 and like a million suns. And even smaller than stellar black holes, we have miniature black holes. Those can just be as big as like an atom, but still have the mass of a large mountain. But the miniature black holes are just hypothetical black holes. They were predicted by Stephen Hawking in 1971, and they are really complicated, so we're just going to ignore them for now. How do black holes form? There are many different ways black holes can happen, but we're just going to talk about the most common form. And to understand that, we need to understand something completely different. What is a star? So, a star is basically a huge collection of mostly hydrogen atoms. In the core of the star, these atoms get fused together, which is called nuclear fusion, and they get fused into helium. Helium gets fused into carbon, and it goes on and on and on until they get fused into iron. This nuclear fusion releases a lot of energy. We can't even imagine how much energy. And this energy creates radiation. The radiation pushes outwards from the core, which balances out the force of gravity pushing inwards onto the core. This basically balances out these two forces and keeps the star stable and keeps it from collapsing onto itself, basically from imploding. But then at some point, all the hydrogen atoms will have turned into helium, and all those helium atoms will have turned into carbon, and so on, until they all turned into iron. The fusion to create iron doesn't release any energy. So there's no more radiation getting created, and there's nothing to balance out the energy pushing inwards onto the core. That's when gravity takes over and crushes everything inside the star smaller and smaller and smaller and smaller until it explodes in a supernova explosion. Well, depending on the size of the star, after the supernova explosion, it can either turn into a neutron star, basically a dead star where no fusion happens and it's super, super dense, or a black hole. Our sun, if it exploded, would not be large enough to turn into a black hole. It would become a neutron star. Now, I also mentioned that there were other ways a black hole could form. So some black holes have existed since the universe began, so since the Big Bang. Others were formed when stars collided or when galaxies are born. So for example, Sagittarius A star, the supermassive black hole at the center of the Milky Way, was created when the Milky Way was born.